This phase change graph is very important. It shows what happens to temperature as a substance is changing phase from one to another. Notice across the bottom of the graph it says heat added. That means that as you're going from left to right, you're adding heat or you're adding heat energy. Energy is what we're talking about. As you go up, what's changing is temperature. So you start down here with a solid, and as you add heat, the temperature increases, and that's what this slanted line represents. The substance is in a solid, but the temperature is increasing. When it reaches a certain point, and that's the point that we call the melting point, then the substance begins to break apart. The particles begin to move away from their rigid solid structure and begin to flow over one another. Notice that as that happens, the substance stays the same temperature. So during the phase change, and in this case we're melting, right? We're going from left to right. We have both solid and liquid during this time, but as energy is being added, the temperature does not change. All that's happening is that the particles are beginning to loosen away from one another and begin to be able to flow over one another. At the point that all of the substance has left the solid phase and the particles are all flowing over one another, the solid becomes a liquid, or the substance becomes a liquid. So this slanty line from here to here, which is labeled C, during this time period, what's going on, again, the whole time heat is being added. But once the substance is all liquid, then the temperature of that liquid begins to increase again and gets hotter and hotter and hotter and hotter until finally the substance reaches its boiling point. Now, during all this time, the substance is liquid, the particles are moving around one another. They're moving faster and faster around one another, but they're not able to break free. They don't have that much energy. Once the substance reaches its boiling point, though, adding more energy gives the particles the energy needed to break away, to begin flying out into a gaseous phase. And so during this next time period, you've got a lot of liquid with just a few particles zipping out into space and becoming a gas, and then less and less liquid and more gas. And that's this part D. Now notice again, during the phase change, in this case it's vaporization, during this time, the temperature does not increase. Temperature does not change during phase changes. So the temperature remains the same, but the particles are being freed up to fly out into space, into a gaseous phase, until finally all of the liquid is gone and it's all gas. Once you have a gas, if you've captured it, typically when we think about heating things, we think about boiling things on a stove. And so we don't capture the gas. But if we captured the gas and continued to add heat, add energy, then the temperature of the gas would begin to increase above the boiling point and get hotter and hotter. That's why sometimes you're told to be very careful when you remove the lid off of a pot of boiling water, because in fact the gas which is captured in there under the lid could well be at a higher temperature than the water itself.